Hey there everybody. In this video we are investigating a device called a mass spectrometer. A mass spectrometer is a device that takes advantage of charged particles' motion through electric and magnetic fields to learn more about their properties. For instance, we know a lot of the fundamental numbers that we know about things like protons, for instance the mass of a proton, by observing their behavior in magnetic fields. As a former organic chemist, I used mass spectrometers almost every day to figure out what things were made out of. This would tell me like how many carbon atoms were in a sample of something versus hydrogen atoms and things like that. And so this is a very critical device to understand. And it has two pieces, so we're going to break this up into two parts. The first part is called a velocity selector. And what a velocity selector is, it's a pair of charged plates, like these right here, that an electric field in between is created. So for this example, I've just drawn an electric field going downward. The actual directions would depend on the design of the machine itself. Over here, we have charged particles entering the region between these two charged plates. So these charged particles here are going to enter the electric field. And I've drawn what are called singly ionized particles. And what that means is that they have one additional proton or electron. Really, you would say one fewer electron or one more electron. So for the purposes of illustration, all these have a positive charge. Singly ionized means they lost one electron, and so their charge would be the charge on one electron. 1.6 times to the negative 19 coulombs. So these might be individual protons. These might be carbon atoms that have had one electron stripped from them. Now, how you actually get this stream of charged particles depends a lot on the design of the machine. There's several ways to do it. What is important here is that all of these things are moving at random speeds, and there's really no way to control the speeds as you ionize things. And so these things are going to be streaming through here at a bunch of different speeds, and our goal is to have only particles with a certain specific speed, let's draw it about yay big and call it V, actually make it through. And so if this particle has velocity v, maybe this particle has velocity 2v, maybe this particle has velocity v over 2. We don't want those to go through because the next part of this is going to depend on us knowing the velocity. And so we have this electric field. In order for us to actually select just these speed particles, what we need to do is introduce a magnetic field. And so let's go ahead and draw a free body diagram of these charges as they move through that electric field. And so here's one of those charges, positive charge. And I chose a positive charge because that's going to give me a force in the same direction as the field, and so the electric force would be downward. So our goal here is to introduce a magnetic field such that we have a balancing magnetic force directed in the opposite direction, such that the forces on our charge of only that velocity such that the net force on charges only with this velocity is 0. And so, well, how do we do that? Well, the electric force, remember, it depends on just the electric field and the size or magnitude of the charge. And so all of these things have the same charge. They should all experience the same electric force. However, the magnetic force depends not only on the size of the charge in the field, but also the velocity. So that's the important thing to remember about the magnetic force here, is that the velocity determines the magnetic force. And so if this is going to be true, and these two forces are going to balance each other, the electric force would have to equal the magnetic force. Then QE would have to equal QVB. And so we would have to have a relationship between the electric field and the magnetic field that looks something like this, Or to kind of put it a different way, we would get charges whose velocity was E over B, electric field over magnetic field. So that's our goal here, is to get charges with only this particular speed to make it through the other side of our velocity selector. And so let's figure out what direction the field needs to be in to give us a magnetic force directed upwards. So right hand rule time. Our thumb is going to go in the direction of the velocity, so that direction. We want a force that is directed upwards. So I'm going to rotate my hand so that my middle finger is pointing upwards. And in order to do that, that means my pointer finger has to be pointing into the page. And so in order for this to happen, you need a magnetic field going into the page, so that would be X's. So for particles that have the velocity that we want to come out of here, that is E over B, they'll make it through because the forces on that particle will be balanced. Things that are going quicker than E over B will experience a net upward force because the magnetic force will be larger than the electric force. And so for 2V and faster particles, our free body diagram would look like this. We'd have a much bigger magnetic force and the same size electric force. So those particles would experience a net force that is directed upwards. And so their path through our velocity selector would be a curve going upwards like that. And they would not make it through. They would collide with the other plate or some sort of, collecting apparatus that we would have for them. Likewise, things that are going too slow, so like something that's going 1/2 V, they would experience a small magnetic force, but still the same size electric force, because the electric force doesn't depend on the speed the same way that the magnetic force does. And so these would have a net downward force and they would curve downward. And so only particles that have the correct velocity V make it through that electric field without being curved one way or the other. And so on this side, we have only particles whose velocity is V. And so if we know what V is, now we can make the second part of this machine work and actually figure out what the mass of this thing is now that we know its velocity. So let's go ahead and indicate this velocity is E over B. So in our next part, we're going to look at the second part of this apparatus, where we put this in just a magnetic field and observe its behavior as it turns to observe how much mass it has.